this video, we're going to take a look at a new way of looking at some data, and that's called this standard deviation. Well, let's consider a couple of classes here. So here are some results from some students who wrote a test in Block A. Let's just say there's only 4 students in the class to keep the data simple. And 4 students also wrote the same test in Block B, and here's their results. So in Block A, 1 student got 78, a student got 79, a student got 77, a student got 78. And in Block B, 4 people wrote the test as well. 1 student got 88, 1 student 91, 1 student 68, 1 student 65. Well, one of the things we could look at is we could figure out what the mean is for each one. And the mean is like the average mark in the class. So the mean, sometimes we use this for the mean, x with a bar on the top. So when you see that, x with a little bar on the top, that just simply means the mean, or the average. So let's figure out the mean for Block A. Remember, to find the mean, we would add all these up. And divide by how many that we have. So we're going to divide by 4. So let's go to the calculator and figure out what the average is for this class. So 78 plus, let's get this over here. Whoop. 78 plus 79 plus 77, oops, plus 78 divided, whoops, make sure I hit equals here, then divided by 4 equals, so Class A or Block A has an average of 78%. So the mean for Block A is 78. The mean for Block B would be 88 plus 91 plus 68 plus 65, all divided by 4. So 88 plus 91 plus 68 plus 65 is 312 divided by 4 is also 78. So it looks like the average in both classes are the same. But we can see that actually the results are very different. In Class A or Block A, almost everybody got the same mark. There was nobody who had a really high score and nobody had a really low score. But in Block B, we had a couple of students who scored really high and a couple of students who scored lower than the average. And so what standard deviation tells us is how spread out the data is. So how far away are each individual scores from the average. So in Block A, we would say that there would be a very small standard deviation because almost everybody is right around the average. So this would have a small standard deviation. Whoops. A small standard deviation here. And Block B would have a large standard deviation because these individual data points are a long ways away from the average of 78. So the standard deviation is really just a measure of how far the data is from the mean or from the average. So a low standard deviation means that the data is close to the mean. All your data, like Block A, all your data is very close to the average. Or a high standard deviation means that the data would be far from the mean. So we would expect this to have a high standard deviation because our data points are spread way out. So how do we calculate? How do we actually calculate or determine what the standard deviation is? So let's do that for Block A. And this does take a bit of time. So let's write down each of the different data points here. And so usually let's make some columns up here. X would represent our data. So 78, 79, 77, and 78. One of the other things that we're going to need to know, or the thing that we're going to need to know next, is what is the data point minus the mean. So remember, x bar is the mean. So really this column is going to tell us how far away is every point from the mean. So remember, the mean here was 78. So on this one, this would be, if we take this point and subtract it from the mean, so 78 minus 78, that's going to be 0. If we take this data point, which was 79, and subtract the mean, so 79 minus 78, that'll be 1. Or in other words, this data point is 1 unit away from the mean. Here, 77 minus 78 would be negative 1. 77 minus the mean. And then here, the last one would be 78 minus the mean, which again is 0. The next thing we're going to do is we're going to take the data point minus the mean and we're going to square it. So we're going to square all of these things. So 0 squared is 0, 1 squared is 1, negative 1 times negative 1 is positive 1, and 0 times 0 is 0. So we've squared all these numbers. What that does is that gives us all positive values, because some of these are obviously going to be positive and some of these are going to be negative when we subtract the mean. The ones that are bigger than the mean will be positive, of course. 79 minus 78 is positive. The ones that are smaller than the mean, when you subtract them, will give us a negative number. But we want to make sure that they're all positive. So we'll square that. That'll make it positive. Then what we're going to do is we are going to calculate some totals here. Just move this out of the way. So the mean was 78. And we're going to add all these up. We're going to find the sum of this column. So we're going to add these all up. 0 plus 1 plus 1 plus 0 is 2. So the sum is 2. Now, sometimes we use this symbol. This is a sigma notation, sigma. And this just means sum. So the sum of the difference from the mean squared is 2. So when you see this sign, it really just means the sum of. Add. This just means add. Add all this stuff up. So that's what I did here. I added up all these values and I got 2. Okay, the next thing we've got to do is we've now got to take these and we've got to divide. So I'm going to take the sum of all of these values and I'm going to divide by n. I'm going to divide by how many different data points I've got. So this would be 2, because that was my sum, divided by the total number of points that I've got is 4. So 2 divided by 4, of course, is a half, or 0.5. And then finally, the last thing we're going to do is we're going to square root this. Because we had squared some data points here, now we're going to square root this. So the standard deviation, and that's given by this little symbol here. It looks like a 0 with a bit of a hat on it. That's the symbol there for standard deviation, is equal to the square root of the sum of the differences squared divided by n. So this would be the square root of 0.5, which is 0.707. Oops. We'll go to 2 decimal places. So 0.71 would be the standard deviation for class A. So let's take a look now at class B. So this is our formula. The standard deviation is equal to the square root of all of these values added up divided by n. So I'm going to get the chart here for block B. So each of those marks again, 88, 91, 88, 91, 68, whoops, 68 and 65. So the next thing to do is to find out how far is each point from the mean. Our mean was 78. So 88 take away 78, would be 10. 91 take away 78 would be 13. 68 subtract 78 is negative 10. And 65 subtract the mean would be negative 13. The next piece of information I've got to do is each one squared. So I'm going to take these differences and square them. That's 100. 13 times 13 is 169. Negative 10 times negative 10 is positive 100. And negative 13 times negative 13 is 169. And now I need to add these all up. Find the sum of all of these things. So the sum would equal, whoa, what have we got here? 18, 7, and 6 would be 13. 1, 2, 3, 4, 5. 538. And now the next thing to do to finish with our formula here, so the square root of the sum we figured out was 538. The sum of these differences squared, divided by how many different points do we have here? We have 4 of them. So now it becomes a calculator question. Figure out what is the square root of, bracket, 538 divided by 4, close bracket, is 11.60. So yeah, we can see that the standard deviation for block A was significantly less than the standard deviation for block B, which was 11.60. Alright, let's consider another example here and find the mean and the standard deviation for this set of data. So here's the time spent studying for a quiz. So we have some intervals here from 0 to 20 minutes. This should be in minutes. 20 to 40 minutes, 40 to 60 minutes, 60 to 80 minutes, so on. So I have one student who studied between 0 and 20 minutes for the test. 5 students studied from between 20 and 40, so on. 10 students, 40 to 60. So what I can do is put on the bottom here some sums. So one of the pieces of information I'm interested in is the total number of students. So 5, 6, 16, 19, 21, 25. So I know that n, the total number of students here, is 25. And now we need to finish calculating some more information. So what else do I need? Well, whenever you have a range of data, what we'll do is we'll just find the midpoint of that. So instead of saying from 0 to 20, let's just say that the average here, the midpoint, is 10 minutes. And between 20 and 40, this will be 30 minutes, and this will be 50, and this will be 70, this will be 90, and this will be 110 minutes. And so then, if I want to find the data minus the mean, that'll be the next piece that I want to do, but I don't have the mean yet. So I've got to determine what the mean is. So how are we going to find the mean? Well, we really have one value of 10. So the mean is going to be 10. I have one of those values. I've got 5 students at 30 minutes. So that's going to be 5 of those. I've got 10 students at 50 minutes. So I've got 10 students at 50, and I've got 3 students at 70, and I've got 2 students at 90, and I've got 4 students at 110. So the mean will be all of this divided by my total. So it's really 10 plus 30 plus 30 plus 30 plus 30 plus 30, because there's 5 of those, and then plus 50, 50, 50, 10 times. So instead of listing those all out, it's easier to just multiply them. So 1 student at 10 plus 5 students at 30 plus 10 students at 50, 3 students at 70, 2 students at 90, and 4 students at 110 for a grand total of 1,490. And I'm going to divide that by 25. This will give me my mean. So 59.6. So 59.6 is now my average. So then, if I take each one of these and subtract it from the mean. Just for simplicity's sake, let's just make this 60. 59.6 will be a bit awkward to work with. So just for simplicity's sake, so midpoint minus the mean. So 10 minus 60 would be negative 50. 30 minus 60 would be negative 30. 50 minus 60, negative 10. 70 minus 6, positive 10. This would be positive 30. And 110 minus 60 would be positive 50. So those would be the data minus the mean. But I'm going to have a whole bunch of these, aren't I? I'm going to have, where are we at? But first, we need to find out what the data minus the mean squared is. So let's square this number, 2500. Negative 30 times negative 30, 900. Negative 10 times negative 10. Positive 100, positive 100, 900, 2500. So there's each of these data points minus the mean squared. And now we need to figure out our sum. So we have one student with a difference of the mean squared at 2500. Here I have a difference of 900, but I've got 5 of those. So 5 times 900 would be 4,500. I'm going to have 10 students with a difference of 100, so that's 1,000. 3 students with a difference of 100, that's 300. 2 students with a difference of 900, 1,800. 4 students at 2,500, which is 10,000. And so now in my sum column, I can add all of these up. So 2,500 plus 4,500 plus 1,000 plus 300 plus 1,800 plus 10,000 is a total of 20,100. So keeping in mind that the standard deviation is equal to the square root of the sum of the differences from the mean squared divided by the total number. Now I have my information I need. 20,100 divided by n, which is 25. So 20,100 divided by 25 gives us a standard deviation of 28.35. So the mean was 60. That was our average. That was the mean. That was the average time that people studied for this test. The standard deviation of this data is 28.35. Now a little later on we'll know what the significance of this number means. For now we just know that if the number is big, that means that there is a big spread of data, and if the number is small, then there'd be a very small spread in the data. So this is a very large standard deviation, which means that students studied for lots of different times, and you can see that one student studied hardly at all, and there was 4 students who studied quite a bit more than 60 minutes. So there's a couple examples of how we can manually calculate the mean and the standard deviation. We'll look now at how we can find the mean and the standard deviation using a graphing calculator. So let's go back to this data that we had for the different test scores in Block A and Block B. So let's find the mean and the standard deviation for Block A. So we'll get our calculator out, and I'm going to show this with the Casio one. If you're using the TI calculator, it's a little bit different, but I'm going to show you with the Casio one because that's the one I have on here. So what we're going to do is we're going to go to Stat, hit Enter, and then you get these lists thing that comes up. We really just have one list of numbers, so I'm just going to enter this data in 78, 79, 77, and 78. So I've entered the data in. You can keep going. There could have been a 5, 6, 7. We are only going to have these 4 values in because that's all we've got here. Then we're going to calculate some stuff. So we're going to hit F2 for calculate. And then we really just have one variable in here, one set of data. So we're going to hit F1 for one variable. And what this does is it gives us a whole whack of information. Now some of this we're not interested in, but one of the things we're interested in is X bar, the mean, which was 78. You can see there's what we calculated when we did it manually, 78. Then this would be the sum of all the X values, 312. So if you added all those up, that's 312. We're not going to worry about that stat. We're not going to worry about adding them all up squared. But this is what we want here, X sigma n, not the n minus 1. So this is the standard deviation, 0.707. You can see that's what we got right there, 0.71. We rounded our answer, remember? And so then we could do this again simply for Block B. I just go type over top 88, 91, 68, and 65. And it's a one variable. And so the mean is also 78, but the standard deviation was 11.60 on that data. And I believe that's what we got. Yep, when we did it manually. So obviously you can see this takes a lot of time to do manually. That's why I only had 4 students here. If you had 30 students in a class, it would take a long time to figure out what the difference from the mean was and then square it, add them all up, divide by the total number in the class and square root it. But you will be expected to manually be able to come up with a standard deviation when you've got a reasonable amount of data to work with. Okay, let's look at the example where we had the students who are studying for the quiz. So this was a little bit different because instead of just some individual data, we had groups of data. We had 1 of those, 5 of those, 10 of those. So you could enter all 25 numbers in, like go get the calculator out, go stat, and put these all in, like go 10, 30, add 5 of these down here, 30 of 5 of, like 5 30s, and then go 10 50s and put 3 70s in and get 25 numbers all strung down here. But it's often quicker, let me just delete these, to just go 10, 30, 50, 70, 90, and 110. Okay, so there's my data. And then over in list 2, we can actually put how many of those we have. So we have 1 of those, we have 5 of those, we have 10 of these, we have 3 of these, 2 of these, and 4 of these. So this information came from here, right? The number of students. I had 4 students at 110, 2 students at 90 minutes. Now, so we have all our data entered in here. Now we'll go calculate. It's always one variable that we're working with in this course. And it comes up from some data here, but we've got to be a bit careful. So let's back up. And there's this thing over here that says set. And this is really important. So under F6, this is where you're telling the calculator where to get that information from. So it says one variable. Ignore the 2 variable stuff. We're not doing that. But one variable, it says where is the list coming from? Where is the actual data? That is in list 1. And if you go back here, see how it says list 1, list 2, list 3? So in list 1, I actually have my data points, the 10, 30, 50, 70, 90, and 110. In list 2, that's where I have my frequency, or the number of students that had those scores. So that's why it's really important that X list should be in list 1 and the frequency we'll put in list 2. So frequency in list 2, you can change these. Like if you had yours the other way around, you could say list should be in, list 2, and then you could go down here and change this so that it's in list 1. Okay, so this would be if you had your data points in your second column and your frequency in your first column. So just make sure that that lines up. So mine is actually list 1 where I put my information in, and the frequency is in list 2. Okay, so just make sure that that's set right. Now when we hit one variable, we're going to get the information we need. So there's the mean, 59.6. Remember, we rounded ours to 60 just so that we could manually do the works easier. Whoops, come back here, calculator. And here's the other piece we want. The mean, the standard deviation of 28.35, and that's what we got with the standard deviation. So that's how we can calculate standard deviation of data. Standard deviation is a measure of how spread out the data is. When the standard deviation is small, you know your data is all clustered around the mean. And when your standard deviation is large, you know your data is all spread out. This is the formula that we would use if we were to manually calculate the standard deviation for our set of data, or we could also use a calculator where it'll do the number crunching for us and figure out our mean and our standard deviation.